Hello students, we are in assignment 10.5 of chapter 10 wave optics. In previous videos, we did see two definitions of diffraction, why we can listen to a person on the other side of wall through open door but we cannot see, and we also saw why center in diffraction pattern is always bright. Now in this video we will see condition for minimum in case of diffraction due to single slit, and also condition for maxima for diffraction pattern in single slit. As we saw earlier that when we consider a single slit diffraction pattern, why center is always bright? So the reason is, we say that there is zero optical part difference. So if I consider this as perpendicular bisector, and then if I consider three waves of a wavefront, we say that to collimate the waves we use convex lens, and then the optical paths are same in terms of length when we consider these three paths, and hence this is the point where path difference PD is 0 lambda. Now this also indicates that if you go further up, you are creating path difference. It will not be 0 lambda, it may be say 0.1 lambda. Further if you go, it may be 0.2 lambda. So there must be some point where path difference becomes 0.5 lambda or else lambda by 2. And what if the path difference is lambda by 2? So if the path difference between two waves is lambda by 2, consider this situation. See, up to this there is no path difference, and now I am adding half wave. So this half wave up to this path difference is 0 between these two, but because of this half lambda, what happens that this 2 will produce dark fringe or destructive interference will take place. So there must be from center, as you go up, there must be some point where the path difference becomes lambda by 2 or maybe 3 lambda by 2 or maybe 5 lambda by 2. So can we figure out exactly at which point the path difference will be odd multiple of lambda by 2? And this is very true even for constructive interference also. There must be some point on the screen somewhere where the path difference is 1 lambda. So the way at 0 lambda we have bright fringe, somewhere here we should have bright fringe. So can we figure out in terms of angle that for which theta value we will have constructive interference taking place or destructive? So let us first try to figure out the condition for dark pattern or minima to take place. We again consider a single slit with width D, and let there be screen at distance capital D. And we consider three waves from a wavefront approaching this slit. So this becomes D by 2, and this also is D by 2. And this is our reference line. Let the center of the screen be O. We will consider the waves to be A, B, C. So now I assume that there is some point P where the intensity is 0, and so we are trying to find out that what is the condition for P point to be dark. So the waves which are bent in that direction are collimated by a lens, and now from previous argument we know that there is no optical path difference. If I take foot of perpendicular from A to say on CP, there is no optical path difference occurring in this part. Okay, why there is no optical path difference? For that, check previous video. It is very similar to central bright, and so there is no optical path difference. So path difference is created because of this triangle. So suppose if I have Cm to be equal to 1 lambda, then automatically let this point be Bn, it will be half lambda. Okay, so what I mean to say is that if you take A and if you take Bn, then on A, if you have this condition, then on Bn you have half wave more. So the path difference between A and this Bn is half lambda. What does it mean? It means that this 2, this 2 will give us destructive interference. Now, what if I take one wave just below A and one wave just below B? Then this 2 will also have path difference of half lambda. Go further. Suppose if you take one wave here and one wave here, this 2 will also have path difference of half lambda. If we take one more wave here, one more wave here, this 2 will also have path difference of half lambda. It means that whichever number of waves you consider between A and B, you will definitely get corresponding wave between BC, whose path difference is half lambda. And ultimately, uh, all the waves between AB are negated or cancelled out by corresponding waves in BC, and hence there is no wave reaching point P, and then the P point will be uh, dark point. So I can say that in triangle, if I consider this triangle ACM, this is put up perpendicular, so it is 90. Let this angle be theta. So sine theta, our assumption was that this gap should be lambda, and this is d. Sine theta has to be lambda by d. If this condition is satisfied, then P point will be dark point. In general, we can say that sine theta may be n lambda by d. Not necessary that it has to be 1 lambda. This argument is true even if it is 1 lambda or 2 lambda or 3 lambda. 0 will not consider because it is central point. Okay, so this is the condition for P point to be dark. Now, if n is 1, you are talking about first minimum. If n is 2, you are talking about second minimum, and so on. So, what is the condition for minima in case of single slit diffraction? This is the condition. Okay. What about maxima? Now, logic for maxima is also very similar. Condition is slightly different. Let us check that also. Again, the same single slit we consider with distance with the width d, and again I have the reference line. I would call this point O, and now we are talking about point P, which is bright point. So now if I consider the waves to be say A, B, C and D in such a way that the difference between them is d by 3. So how much it is? This is d by 3 each. And now again the waves which are bent in this particular direction are collimated at point P using lens of focal length f. And so what happens? So again, if I take foot of perpendicular, say here, let it be M, there is no path difference from AM up to P. Why there is no path difference? Because optical distance traveled is same. Okay, so This part will not discuss. It is not playing any role for point P to be bright or dark. It is not useful part. Before slit, there is no part difference created. So whatever part difference is created is in this triangle. Which triangle? Triangle A D M. Now assume that dm is lambda by 2. So if dm is say, sorry, not lambda by 2, 3 lambda by 2, then what will be cn? It will be 1 lambda. If this is, let me remove this t by 3. So d by 3 I am putting here, and now I assume that dm is 3 lambda by 2, 1.5 wave. So automatically you will have half wave here. Let this point be q. So this condition is similar to previous case. So I can say that all the waves between AB and all the waves between BC, they have path difference of half lambda. And so the resultant is destructive. But then I have this part, waves in CD, which are not being cancelled out. So all the waves, all these waves will reach point P without any disturbance, without any uh, separation, and hence P point will be bright point. So I can say that if this condition is satisfied, then P point will be bright point. So how do we express it? So we can say that if sine theta in this triangle ADM becomes equal to 3 lambda by 2 upon, how much is this? It is width of the slit D. So if it is 3 by 2 lambda by D, then the P point will be bright. In general, we can say that it should be 2n plus 1 lambda by 2d, where n starts from 1, 2, 3. So this is the condition for maxima in case of diffraction due to single slit. Thank you.